Hey guys, this is the Space Train, your daily express till the edge of the space. And today we will talk about, what is a black hole? If you are ready, grab your tickets and let's go. Our train will explore the whole universe to find answers to some important questions. So make sure you have subscribed to get unlimited pass on our expedition. What is a black hole? A black hole is a location in space with such a strong gravitational field that the escape velocity exceeds the speed of light. What this means is that you require a velocity greater than the speed of light, a physical impossibility, to escape the black hole, as can be seen in the in general relativity. Mass warps space-time depending on a mass density, and so when you pack a lot of mass in a very small area, space-time curves so severely that it traps even light. Since a black hole does not reflect, apart, potentially, from the nearly undetectable Hawking radiation, it is thus completely black. The image below is a nice analogy for a black hole, where, beyond a certain point, the water current is so strong that no speed will be sufficient to escape it. When a star dies, all of its mass gets concentrated into a small amount of volume, so it attracts objects near to it with a tremendous amount of pull. If you were to throw a ball from a black hole to space, you would have to throw with an infinite velocity, infinitely higher than any number that you can think of, and also infinitely higher than 1,079,252,848.8 kilometers per hour, that is the speed of light. So even if light enters the black hole, it can't come back after reflection. As light has the highest velocity in the universe, no other object can escape from a black hole too when it gets near to a certain extent. How is a black hole formed? It all starts with a massive star. As the star fuses hydrogen into heavier elements, a process called thermonuclear fusion, the heat produced creates an outward pressure, which acts against the inward force from gravity. In essence, the thermal pressure prevents the star from collapsing under its own gravity, and as long as the star has fuel to fuse and create heat, the thermal pressure and gravity are in balance. At one point the star runs out of fuel, which means the thermal pressure decreases, and gravity takes over. This is when a core collapse occurs. Stars with an end mass below the Chandrasekhar limit of 1.4 times the mass of the Sun will collapse into white dwarfs. Stars with an end mass between the Chandrasekhar limit and the Tolman-Oppenheimer-Volkoff limit, TOV limit, of 2 to 3 times the mass of the Sun will become neutron stars, and stars with an end mass above the TOV limit will become black holes. This end mass correlates with an initial mass of at least 25 times the mass of the Sun. Black hole is one of the most incredible phenomenon of nature, and it has intrigued scientists and average people alike for decades. Events that occur in the nearby region of the black hole seem to be like out of the greatest science fiction book one can ever read. Black holes are completely characterized by only 3 parameters: mass, rotation and charge. There are now thought to be 4 main types of black holes if classified by mass. Primordial black holes have masses comparable to or less than that of the Earth. These purely hypothetical objects could have been formed through the gravitational collapse of regions of high density at the time of the Big Bang. Stellar mass black holes have masses between about 4 and 15 solar masses and result from the core collapse of a massive star at the end of its life. Intermediate mass black holes of perhaps a few thousand solar masses may also exist. Sketchy evidence suggests that they may be found in some clusters of stars, and may eventually grow into supermassive black holes. Supermassive black holes weigh between 106 and 109 solar masses and are found at the centers of most large galaxies. Alternatively, black holes can be classified by their 2 other properties of rotation and charge. Schwarzschild black hole, otherwise known as a static black hole, does not rotate and has no electric charge. It is characterized solely by its mass. occur black hole is a more realistic scenario. This is a rotating black hole with no electrical charge. Charged black hole can be of two types. A charged, non-rotating black hole is known as a Reissner-Nordstrom black hole. A charged, rotating black hole is called a Kerr-Newman black hole. Under the classical theory of general relativity, once a black hole is created, it will last forever since nothing can escape it. However, if quantum mechanics is also considered, it turns out that all black holes will eventually evaporate as they slowly leak Hawking radiation. This means that the lifetime of a black hole is dependent on its mass, with smaller black holes evaporating faster than larger ones. For example, a black hole of 1 solar mass takes 1067 years to evaporate, much longer than the current age of the universe, while a black hole of only 1011 kilograms will evaporate within 3 billion years. There are lots of questions left, so don't space out, and leave some space in your brain for answers. I hope you enjoyed this video. If you want to see more, subscribe and click the bell button to get notifications on our latest videos. If you are still here, grab your knowledge and get out of my train.